So hello friends, welcome back to our channel STM Metatronics. So in this video we will continue with our SPI like TFT driver development code. Okay, in the last video we have gone through the data sheet and we were till this point, right? Display data RAM. So the TFT display that we are going to interface is of 132 into 162 pixels. Okay, and each pixels have R, G and B. Okay, the TFT display that we are going to use are the TFT display we are going to use in the 18-bit graphic mode. Okay, so what it means is RGB will constitute total will constitute 18 bits. Okay, so R will require 6 bits of data. G will require that green pixel will require 6 bits of data and blue pixel will require 6 bits of data. Total 18 bit of data required for the each pixel. Okay, now so with the 18 bit per pixel resolution we can have total 262k colors. Okay, now we will see like what is the how we can display that first thing. Okay, now one more thing that I want to mention over here, like that we will be using in our that we will be using in our code is like, so we have total 132 into 162 pixels, right? And each pixels is consisting of like R, G and B. Okay, likewise, so in horizontal we have 132 and in vertical we have 162. Okay, so you can see the numbering. So here they have mentioned this 132 into 160 bit resolution. Okay, yeah, so here we have 132 into 162 resolution into RGB, right? For this we have to set these bits as 00, SMX, SMY and sRGB as 0. Okay, so we have made this connection in our circuitry, right? SMX, SMY and sRGB as 0. So this is considered as 0, right? This is connected to 0, this is connected to 0. Okay, so don't get confused, I'll highlight the net, right? So you can see that sRGB, SMX and SMY, those are all connected to ground. Okay, so GM1 and GM0 we have to make it as 00. So GM1 and GM0, GM1 and GM0 we have connected it to ground also. So that's the connection. That's the way that we can select 132 into 162 with resolution, pixel resolution. Okay, now in the horizontal line we have total 162 pixels and each pixel will have red, green and blue LED. Now each LED will require 6 bits of data. Okay, so that's the horizontal representation, row representation. And in column, right, we have total 162 pixels. Okay, so from 0 to 161, right, and from 0 to 161. Now you will get confused, either you will you will try to understand what is this representation from 0 to 161 and here it is given as 0 to 161 in reverse order, right? Same goes for 0 to 161, 0 to 161, right? From 0 to 161, 131 to 0, likewise, right? So basically this is row representation. Okay, and this is row and this is column. Okay, and this is segment. Basically we will see those abbreviations. Okay, scan address, row address, column address, scan address. Okay, when we select the row address as my equals to 0, okay, so basically it will start row address going from 0 to 161. Okay, and when we select the column address mx equals to 0, then we will be scanning in, or we will be putting the data like from first column to 131 column. Okay, so this is likewise. So if we set my equals to 0 and mx equals to 0, we will be filling each pixel from top end to bottom end. Okay, if we change that orientation, so my equals to 1 and mx equals to 1, so we will be filling the data from 0 from bottom corner to top corner. Okay, now ml is scan direction. Okay, so scanning can be happening from this direction or this direction, that we can set using ml equals to 0 or ml equals to 1. We will see this in our coding, like how we want to represent the data. Now there is also equals to mx equals to 0, my equals to 0. These are the mirror things. Okay, so when we write the data and we set the mx bit to 1, right, we will be having the horizontal mirror. When we set the my mirror, we will have the vertical mirror, and if we set both, we will have horizontal plus vertical. Okay, so that representation we can do. Now we will go over here. This is normal mode display. Okay, this is 132 into 162 resolution. Okay, now see over here, mx, my, ml equals to 0, smy, smx equals to 0. Okay, how the data will be filled? It will be filled in this order. It will start from over here, it will go over here, it will come to this second row, it will fill up the second row, it will go on the third row, it will fill up the data on third row, it will go to the fourth row, fill up to the end of the row, go to the next row, fill up till the end of the row. Likewise, now it will come to the end row, it will start from the end row first column, and it will come to the end row end column. Okay, likewise we will have the data that is filled up. Okay, now see, this is beginning, this is end, so data will be starting from the beginning point, that is 0 0, and it will start over here 0 comma 132, it will come over here 132 comma 0. Likewise it will go to the next row, it will fill up the data, it will come to the end of the row, it will go to the next row, start of the next row, it will fill up the data till the end of the row. Likewise we will start with the columns. Okay, now it will come to the end row end column. Likewise. Okay, now the data that we have to fill, like 18-bit data, right, so it will be in this order. So the right, now this is mx and my representation. What will happen if we set the both the bits to or if we set individual bit? Okay, there are total 4 possibilities depending on the mx and my. Okay, so if we keep these bits at 0 0, then we will have the normal picture. If you want flipped picture, right, we will set the my mirror. Okay, if you want mirrored image, okay, horizontal mirrored image, then we will set only mx bit, we will keep the my bit as 0. Okay, so we will have the flipped image. Now if we set both the images, we will have flipped vertical and horizontal image. Okay, now if we change the mv, okay, mv bit, then we will have this representation orientation. Okay, and along with this mv bit, we will have the flipped images. Now we will see, we will go to the part, then we will see. Okay, now this is the flowchart, power on flowchart. Okay, this one is important. So in normal LCD display, right, character LCD display, we have set of commands written in order to display the character properly, right? We have to clear the LCD, then we have to set the resolution, then we have to send few commands in order to get the cursor on the first line, first column, right? Then we will use the cursor blinking or not. Likewise, now these are the sequential patterns that we have to do, or right. So in order to get the TFT display working, we have to also send few commands. Okay, once the LED is powered on, when we give the power, right? It is powered on. Now we have this power on sequence. This can be hardware reset or software reset. So once the LED is on, it will go into the sleep mode. Okay. Now sleep mode, normal display mode on, and idle mode off. This is the default state of the TFT display. Okay. Now what we have to do is we have to make it sleep out. So from sleep in to we have to make it in the sleep out. So first thing what we'll have to do is first command will be our sleep out. Okay, I'll mark it over here. First command 1. Okay, this is initialization command, that's why I'm writing as init command. Okay, so init command 1. Okay. Now once the device is in the sleep out mode, okay, we'll have the normal display mode on and idle mode off. Correct. Now if you want to make the partial mode on, we can have that partial mode on, right? Then the idle mode off will be off. Okay, if not, we can directly go from sleep in sleep out mode. Okay, if we want to have the idle mode on, right, we will be in the sleep in mode. These will be the conditions. Then we have to take it to sleep out mode, normal display mode, idle mode on. Okay, then we can go to the partial mode, normal mode on, and normal mode off. So basically, like, first command that we have to do send is sleep out mode. Okay, and then we can have the rest of the commands. Now these are the default conditions, right? Default states of the registers of the TFT display. So the start address will be 0x00, right? End address will be 7FH. Now there are multiple modes. After power on, what will be the state? After hardware reset, what will be the state? And after software reset, what will be the state? Okay, now if you see sleep in or sleep out, the device will be in the sleep in mode. Okay, frame memory random, no change. If display on off, display will be off. So after sleep out mode, what we'll have to do is we'll have to make the display on. Okay, display mode on after hardware reset, power on, or this is the normal display mode on. Display inversion, it is off. Okay, display idle mode on off, this is the idle mode will be off. Now the start address column, right, start address and end address, this will be given over here. These are the default state basically. So we are going through the data sheet and we will see what it represents, right? So the row addresses are given, gamma setting are also given, RGB for 4K and 64K method mode, this is given. Okay, partial start address, this is also given. Tearing mode off. Okay, tearing mode effect. Then memory data access control, this is mem DAC. Okay, this is also given 000000 MY MX MV ML RGB. Okay, interface pixel, now this is by default it is in 18-bit. Okay, now these are the read commands. Okay, basically now this is for our interest, right? Okay, now yes, these are the commands that we want to operate on, right? And we will be seeing what this command mean. Okay, so first one is the no operation, that is no, it does not perform any operation and its hex code is 0x00. Okay, Then software reset. If you want at any point of time, if you want to reset the TFT display, we can have this software command, software reset command. Its opcode is 0x01. Okay. Then read device ID. Okay, read display ID basically. So if you see, right, we have this opcode. Now we have this dummy read, and then we have like the ID will be sent. If you see, like we have total 1 byte, 2 byte and 3 byte of data. Okay, so after sending this read display ID command, right, we have to send 4 bytes of data, or we have to read the 4 bytes of data. Okay, so this is the method. Basically these commands are given with the parameters that we want to read, right, number of parameters and the parameters that we want to read and what it means. Okay, in the first will be the dummy read byte. In the second byte we will have ID1, in the third byte we will have ID2, and in the fourth byte we will have ID3. Okay, so it will be split in the bytes. Now read display status, we will have this read display status command. Okay, its opcode is 0x09. Then we have read display power, its opcode is 0x01. Now we have this read display. Okay, its opcode is 0x0b. Now read column mode. Okay, basically this read memory access data control. Okay, so we'll have all these settings, that is MY, MX, MV, ML, RGB, MH, right, all these settings will be read. We have then read column mode, read display, dummy read. We have IFPF2, IFPF1 and IFPF0. The whole basically what these commandments is given below, just below the command list. Okay, now coming to this page, right, we have slip in slip out command and its opcode. The reference is given over here, 10.1.11. now we are at the 10.1.2 section, right? So we'll go and we will see what it means, like when these commands can be given. Okay, first we'll see the opcodes. Now these opcodes are very essential for our understanding and the operation of the TFT display, right, working of the TFT display. Now the opcode for slip out is 11H. Okay, for slip in we have 10H. These are hexadecimal opcodes. Then if you want to use the display in the partial mode, right, we have 12H. When we want to have the normal display on, we'll have 13H. Okay, partial display mode on. Then when we want to have the inversion off, we'll have to send 20H. When we want to make inversion on, we'll have to send 21H. Now gamma curve set, we'll have to send 26H, and with that we'll have to send one extra byte for the gamma curve setting. Okay, now display off, we have 28H. For display on, we'll have to send 29H. Okay, for column address set, that is CA set, we will have to send 2AH, right? Then row address set, we'll have to send 2BH. Okay, so for the column address and for the row address, we have total 4 bytes of data that we'll have to send with this command. Okay, now XS means starting address of the column. Okay, and XE means end address of the column. Similarly for YS means row address, row starting address and row end address. So these are total 2 bytes of data. For starting address 2 bytes, for end address 2 bytes. Okay, now coming over here, RAM write. Okay, then memory write the data. Okay, what data we want to write, that we have to send. Okay, RGB set, then LUT for 6K to 56K, 65K to 62K colors. Okay, then the RAM read, memory read, dummy read, and read data. Then partial start address set, partial end address set, that we can set from this command. Okay, then if you want to have the tearing effect on, we can send the 34H. Okay, tearing effect on tearing effect of 34H, tearing effect on 35H, and then the mode. Okay, so there is one parameter with the 35H. Then memory access data control. Okay, memory data access control. So with this 36H, we have to send one parameter also. Idle mode off, idle mode on. Okay, column mode, interface pixel format, read device ID, read device ID 2, read device ID 3. Okay, then for no operation, so as I have mentioned, right, then we have the detailed description for each command. Okay, so for no operation we have 0x00. For software reset we have 0x01. Now if you come over here, right, and see, like, the flowchart is given. When we send the software reset, right, the display holds black screen. Okay, then what we have to send is set command, okay, to software default value. So whatever we, command that we want to send, we can set the commands to software, right, default values, and then sleep in mode. It will go into the sleep in mode. Now we'll have to use the sleep out mode. Okay, so over here, if software reset is applied during the sleep in mode, it will be necessary to wait for 120 milliseconds, okay, before sending the next command. So this delay also we have to take care into the consideration. Okay, so whenever we are giving the software reset, we must give 120 milliseconds of delay after the software reset command. Okay, now these are read device ID. We won't be going through the read device ID commands for now. Okay, because we want to get our display in the working state first thing. Okay, now see, for sleep in mode we have 10H. Okay, now we have to read the description and the restriction, right. This command has no effect when the module is already in the sleep mode. Okay, sleep in mode can only be exited by the sleep out mode command, that is 11H. When IC is in sleep in mode, display on mode, it is necessary to wait for 120 milliseconds before sending the next command. So again we have to give the delay of 120 milliseconds before sending the next command. Okay, so sleep in mode, okay, the display whole black screen, automatic, no effect to display on off commands. Now drain charge from LCD panel. Okay, stop DC-DC conversion and stop internal oscillator, and then go to the sleep mode. So this is the flowchart for, like, when we give the sleep in mode, what happens basically. So it is mentioned over here in the flowchart. Okay, now these are the internal operations that take care. Now if we want to get out of the sleep mode, right, we have to send the 11H command. Okay, no parameters has to be given. Okay. When IC is in sleep in mode, it is necessary to wait for 120 milliseconds. So before like, if we are sending the sleep out command, right, if the display is in sleep in mode, we have to wait for 120 milliseconds. Once the 120 milliseconds are completed, then only we can send the sleep out command. Okay, else the sleep out mode won't be having any effect. When the IC is in sleep out mode, it is sleep out mode, right? It is necessary to wait for 120 milliseconds before sending the next command. So again, after sending this sleep out mode, right, we have to wait for the 120 milliseconds. So this is the internal flow chart, right? Once the sleep out command is received, it starts the internal oscillator, it starts up the DC to DC conversion, charge offset voltage for LCD panel, then display whole bank screen for 2 frames, display memory contents, okay, and then it will get out at the end of the sleep mode. Okay, currently we won't be using this partial mode, right, partial display mode, so I'm not going in detail for this. So we are going to use the normal display mode on and off. Okay, so for this we have to send 0x13h 13 hexadecimal. Okay, 13 hexadecimal. So here there are no restrictions. Okay, so to see the partial definition description for details when we use the command, so for flowchart we have to go to this section. Okay, now inversion on and off, this we will be using. Okay, this we will see. For inversion off, we have to send 20h. Okay, what it does is basically top left to bottom left, it turns off the inversion. So display inversion on mode, we send the command, it will turn off the inversion mode off. Okay, now inversion mode on, right, when we turn on the inversion mode, what will happen is we have to send 21h for to invert the display contents of the display. So basically whatever the contents are there, right, its value, white pixels will be turned into black, right, black pixel will turn into white, and whatever pixel bits we have set, it will get inverted. So zeros will be converted into ones, and ones will be converted into zeros. Okay, so display is in inversion off mode, we send the command, then display will be in the inversion mode on. Okay, there is no delay that is mentioned over here, so we can give the minimum delay required of 1 machine cycle, or we can give the NOP instruction basically. Now gamma set, we are not going in detail with for the gamma set, right. Display off, right, so when we turn off the display, right, basically whatever characters are being displayed, it will just turn off the display. Okay, and to turn off the display, we have to send 21h. Okay, display on mode, we send the command, the display will be off immediately. Now display on, right, so if the display is on, it will have no effect, right. Display on, to turn on the display we will have to send 29h, right. See, the command is used to recover from the display off mode. Output from the frame memory is enabled. This command makes no change to the contents of the frame memory. Okay, so if the display is in off mode, we send the command, display will be on. Okay, now just like our character display, we can set the column address and row address, right. Now to set the column address, we have to send 2AH command. Okay, and along with that we have to send 4 bytes of data. Now what does these 4 bytes of data means, right? First 2 bytes are for the starting address of the column, and next 2 bytes will be the end address of the column. Okay, so column address set, we send the first parameter starting address, we send the second parameter end address. Okay, now this is row set, RA set, this is not pass set, this is a mistake, we have RA set, first parameter, second parameter. Okay, then we have RAM write, then we send the image data. Okay, so this is the flow chart. First we have to send the column address set, row address set, then we send the RAM write command, and then we send the display data. Okay, image data. Again for the row address set, same thing, but the command is 2bh row address set, column address set, and the data. Now this can be used for the animation purpose. If you want to display the same memory contents, right, but on the different location, then we can just move the row address and the column address, right, in our accordance. Okay, same row address set, column address set, RAM write command. Okay, and then image data. Now next one we have this RAM write command. What this command does is, in all color modes there is no restriction on the length of the parameters. So we are going to use into 132 into 162 mode display color, right? So memory range is this. So when we send the RAM write command, we have to send the display data. Okay, basically, and then we can send any command. Now we have RGB set command. This command is used to define the LUT for 12-bit to 16-bit, or in 16-bit to 18-bit color depth conversion. Okay. Now we have memory read command. We are not going to go in depth of the memory read. Partial mode on, partial mode off, display mode on, display mode off. Now to leave the partial mode, what we have to do is display off, normal mode on, partial mode off, RAM write, and then we have to send the data, and then we have to send the display on. Okay, we are not going to go in depth of the tearing effect. Okay, now this is memory data access control. Okay, so this command sets the how we want to display the image, basically. Okay, MY, that is mirror in like horizontal or vertical, right? MY MX is for displaying or mirroring the display. Okay, basically horizontal and vertical. Okay, this is vertical scanning, MV. Okay, this is ML is vertical refresh, basically LCD refresh. Now RGB, see, this is RGB is one important parameter. If we set this bit to 0, then we have RGB filter. If we set this filter to 1, then we have BGR filter. So whatever data, first 6 bits of data, right, first byte of data from which we are going to extract the 6 bits, that will be assigned to the blue LED, blue pixel, right, blue LED pixel. When we set this bit to 1, and if we set this bit to 0, then it will be sent for the red LED. Okay, then horizontal refresh order. Okay, idle mode off, idle mode on. Okay, now see, we are going to use the 18-bit pixel, right, 18-bit per pixel format. So we have to send 3AH, right, and the next command is like IFPF, right, that is interface pixel format, right. So for that we have to send 110, that is 6. So 3AH06H. Likewise we have to send the command. Okay, now this is read ID1, read ID2, and then we have read ID3. Okay, now read sorry, these are the panel functions. So we are going to we are going through the basic register or basic commands, right? Because we want to first turn off the turn on the display, insert some patterns over there, or to display any color on the whole LCD, right? Sorry, whole TFT display, right? Then we will change the display color, then we will send some patterns, right? Likewise we will start. So we are for that I'm not going in depth with each and every command. Okay, these are the connection diagrams given, right? We are going to use 4-line serial MCU interface, right? For that what we have to do is IM2, IM1, IM0 to make it as 00 ground, and we have to make the SPI 4 wire pin to 1. Okay, so that's it for this video. In the next video we will walk through the code. We'll see how we have given these commands, right? We have seen each and individual command, right? Necessary commands first we have seen. We have seen the delay that is required, right? Slip in, slip out mode, set the column modes, right? Then set the memory access, data control mode, set the pixel formats and everything, right? Then turn on the display, set the pixels, right? Now I have already developed the code. I'll just build it. And I'll show it to you. So load the hex file. If you can see that this is the current timing, right? Current timing of my local computer, right? And it is matching, exactly matching. Okay, so if I can see, the whole display was white, right? Then starting from the top corner to bottom corner, I was writing the pixels, and those pixels were getting directly written. Now if you see, I have different patterns that are visible on the LCD in different formats, right? Now it started to fill up the display with the slightly red LED, again the white display. Okay, now see, this is one pattern, right? Now the display is more reddish, again white display, right? So I'll tell you how I programmed this, what are the commands that I have sent. Okay, I can change the orientation starting from over here to different orientation, right? So if you see each time, like each time the whole display color is getting red and red, it is getting more brighter and brighter. So how I did that, we'll see through the program also. Okay, but that we'll keep that for the next video. So thanks for watching this video. If you like my explanation, give it a like, share with your friends, and subscribe to our channel. We'll see you in the next video.